One way out of this dilemma of why is it so big is if it was targeting the inner solar system by design. And indeed, the trajectory is aligned with the plane of the planets around the sun to within 5 degrees. The chance for that at random is 1 in 500, okay? And it's moving in a retrograde trajectory opposite to the motion of the planets, which is ideal for it to release mini probes that will get into the planets. It gets close to Mars, it gets close to Jupiter, it goes on the opposite side of the sun relative to Earth when it's closest to the sun. And that's the time when a spacecraft could do a maneuver to take advantage of the sun's gravitational assist. All of these are interesting indications that may imply that some intelligence designed the trajectory. So I had one sentence at the end of the paper saying maybe the trajectory was designed.
As 3I Atlas approached the immense gravitational domain of Jupiter, it crossed an invisible but decisive boundary, the Hill sphere. This is not just a line in space, it's the limit where Jupiter's gravity becomes dominant over the Sun's. Inside this sphere, any object, comet, asteroid, or spacecraft, becomes more influenced by Jupiter than by the Sun. For most comets, crossing into a planetary Hill sphere results in either rapid capture or a gravitational slingshot. But 3I Atlas didn't follow either path. Instead, the object exhibited a gradual deceleration that no known passive forces could explain. Data from multiple observation points, including Doppler radar from ESA's deep space antennas and the Japanese JAXA infrared monitoring grid, showed that 3I Atlas reduced its approach speed at an unexpected rate. Normally, gravity from Jupiter would cause an acceleration spike, but here, a flattening of the velocity curve was recorded. The object didn't plunge inward. It hesitated as though aware of the boundary it had just crossed. Scientists call this kind of motion non-ballistic, meaning it doesn't match the predictions of standard orbital dynamics. In spacecraft, such movements usually signal onboard course correction. In natural objects, they don't happen. There are no thrusters, no known chemical reactions. And yet, something about 3I Atlas allowed it to begin modifying its approach in real time. The implications of this are hard to overstate. Inside Jupiter's Hill sphere, small trajectory changes can have massive orbital consequences. And here, the object seemed to act with precision. It chose a path, it controlled its speed, and with every passing kilometre, it began to act less like a comet and more like a vehicle navigating an unfamiliar planetary system with intent. When analysts reviewed the velocity profile of 3I Atlas, a remarkable detail stood out. The object was slowing down and not due to natural drag. Across a monitoring window of 9 hours, its velocity relative to Jupiter declined by over 10 meters per second. While such a figure might seem small on Earth, in space it's massive. To decelerate in a gravitational well without propulsion requires an external force or internal control mechanism, and yet neither appeared present. This wasn't a chaotic stop, it was elegant. Instruments tracked the drop as a near-parabolic curve, one that engineers immediately recognized as a controlled descent profile. Planetary scientists and mission planners use similar curves when guiding probes toward orbital insertion. But this was an interstellar object with no known mechanism on board, or at least none visible. Adding to the intrigue was the directionality of the slowdown. It wasn't a straight deceleration along its previous trajectory. Instead, there was a slight angular shift. That ruled out possibilities like radiation pressure or impact with particles. It also dismissed any idea of gas, jets causing the deceleration. There were no thermal surges, no pressure spikes, no chemical releases. For scientists observing this from Earth, this velocity drop changed everything. It introduced the idea that the object might be under intelligent control, or following physical rules not yet understood. If something could manipulate its own motion inside a gas giant's Hill sphere, it meant we were no longer observing a passive visitor. We were witnessing behaviour. As one physicist noted, nature doesn't do this cleanly, but design might. The question now was not just what 3I Atlas is, but who or what might have sent it. Roughly 1 hour after the deceleration began, a second anomaly unfolded, and it shocked even the most sceptical analysts. 3I Atlas changed direction. Not slightly, not due to turbulence, but clearly. The path shifted by approximately 0.9 degrees in a lateral movement relative to Jupiter's gravitational centre. In deep space dynamics, that's not a small nudge, it's a purposeful redirection. But here's the problem. No outgassing occurred, nothing vented from its surface. Normally, when comets shift their path, it's due to sudden release of gas or ice. Jets form from beneath the surface, spin the object and change its direction. Telescopes can usually see this in the infrared spectrum or as reflected sunlight distortions. This time, there was nothing. Spectral bands showed no change. Thermal sensors aboard the Lunar Gateway Relay Station, normally used for far-side lunar weather, picked up no heat burst. Instead, 3I Atlas appeared to drift smoothly into its new heading. The adjustment took 46 minutes. Its curvature was almost too perfect. What happened next raised eyebrows in both academic and classified communities. The lateral shift matched a known maneuvering arc from an ESA propulsion database, one designed for orbital braking without thrust, using gravitational eddies as steering mechanisms. In short, it matched a simulated maneuver from a system built to move without engines. And yet this object had no engines, no visible modules, no sail, no heat output, just mass and control. That contradiction opened up a line of inquiry that continues even now. Is there a new category of interstellar object that regulates its trajectory without fuel? Or was this object engineered for something far more complex than we're ready to understand? After the course correction ended, something even more extraordinary occurred. 3's Atlas didn't continue on a looping orbit or dive deeper into Jupiter's influence. Instead, it hovered. Not in the literal sense. Hovering is impossible in a vacuum, but in mathematical terms it held position. For almost 40 minutes, the object remained in what scientists call a gravitational null corridor, a region where the pull of Jupiter and the Sun are near equal. It's a fragile place. Natural bodies usually pass through it in seconds. There's no air resistance to slow them down, and yet 3I Atlas coasted. It behaved like it was maintaining station keeping, something only spacecraft do. This defied expectations. Analysts expected continued acceleration, or a gravitational spiral. Instead, the object's kinetic profile flatlined. Its relative velocity to Jupiter dropped to near zero, and while the forces acting on it fluctuated, the object compensated, staying locked within a corridor just a few hundred kilometers wide. What made this especially eerie was the lack of spin. Most comets tumble. They wobble due to uneven mass distribution. But during the hovering phase, 3I Atlas became rotationally still. Telescopic images showed a fixed orientation, like a camera holding a gaze. That doesn't happen naturally. It requires balancing. Some experts believe the object was waiting, aligning itself before continuing. Others suggest it was testing Jupiter's magnetic fields, scanning for something. But whatever its goal, it behaved more like a probe preparing for insertion than a comet drifting aimlessly. And when it finally moved again, it didn't fall, it navigated. At the conclusion of the hovering phase, instruments recorded an event that has since divided the scientific community. A sudden, sharp spike in reflectivity appeared across multiple bands. Particularly in the near-infrared and visible light spectrums, it lasted only 18 seconds. But it was enough to force a re-evaluation of what kind of object this might be. Reflectivity spikes are rare, but not unheard of in comet studies. Normally, they result from sudden ice exposure, rotational glints, or energetic venting. But here, none of those mechanisms applied. The coma didn't expand. No particles were ejected. There was no material shedding, no thermal spike, and no fragmentation. Instead, the spike followed a clean sinusoidal profile, rising and falling with symmetry. That curve told researchers that something on the surface had moved. Perhaps a flat panel, perhaps an array of crystallized material, perhaps something else entirely. What stood out was the angle. Solar light hit the object at 27 degrees, a known sweet spot for directional reorientation if one were trying to reflect or receive signals. In fact, some classified satellite tracking stations observed a corresponding radio silence during the same 18 seconds, as if electromagnetic activity had been briefly masked or absorbed. One theory posits that the object reoriented itself deliberately, either to align with Jupiter's magnetosphere or to prepare for incoming radiation. Another theory suggests a metallic surface temporarily angled toward the Sun, producing a specular reflection far stronger than icy crust alone could account for. No natural comet has ever demonstrated this kind of behavior, and while some researchers continue to argue for exotic mineral alignments or rare phase changes in surface ice, others are starting to wonder whether what we witnessed was a deliberate calibration, the kind seen in pre-programmed orbital sequences. We now find ourselves watching the sky not just with curiosity, but with a growing sense of reverence. 3i Atlas has entered the gravitational influence of Jupiter and done something no interstellar object has ever done before. It slowed when it should have accelerated, it hovered when it should have fallen, and it followed a trajectory so precise, so deliberate, that even seasoned astrophysicists are struggling to classify what they've just witnessed. This wasn't just a deviation from what we expected, it was a reminder of how much we still don't understand. Whether 3i Atlas is a natural anomaly obeying physics we have yet to define, or something else entirely, the implications stretch far beyond this moment, because the solar system is not empty. And perhaps it never was. The more we observe, the more it seems that space is not a void, but a stage. One object just crossed into the realm of the giants, danced along a stability line, and took its place among the forces that shape our cosmic neighbourhood. We don't yet know if it will stay, we don't know what it's waiting for, but we do know that it's not finished. If you want to follow its next move, and be among the first to understand what it could mean, make sure you subscribe. Share this update with someone who still thinks all comets are the same, and tell me in the comments where you're listening from, and what you think 3i Atlas really is. Something just parked near Jupiter, and the silence it brought with it is only getting louder.